Thank you for reminding me, Trent. I appreciate that. All right, so when we talk about real numbers, there's several different categories that they all fall into. The very smallest group of real numbers, very smallest, I'm going to draw myself a little box to represent that's the smallest, is called our natural numbers. Natural numbers are our counting numbers. Well, every number we count with. Yep, those are all counting numbers. So those are natural numbers. Now the next bigger category that includes all of those natural numbers is called the whole numbers. Whole numbers are counting numbers and zero. All right, so we're only adding one more number to it. It goes in the next category of whole. Good, Sean. Yes. The next category, which includes all of those, these are called integers. Integers are your counting numbers, 1, 2, 3, and their opposites, yes, -1, -2, -3. And of course, we still have to include 0. Yep, and 0. So the number 3, for example, is all of those. It's a natural, it's a whole, and it's an integer. But if I just said, what is -7, that's only an integer. Okay? All right, next. Next one. The next biggest one, which includes everything, is our rational numbers. Yes, a rational number is any number that can be written as a fraction. So -10, for example, can be written as -10/1 or -20/2, right? So that makes it rational. 1/3 can be written, right? That's a fraction. If I did the square root of 4 is actually the number 2. That can be written in a fraction. So we can do a lot of different ways. If it can be written as a fraction, it is rational. Now there's one more category that doesn't include any of those. That special category, good, is irrational. All right. Irrational. And I know you've heard this definition from me many, many times. Irrational is non-terminating, which means it doesn't stop, non-repeating decimal. So if I have 0.33333 repeating, that's not irrational, right? Yes. And then it goes 6, 2, 3. Yep, that's not irrational. Okay? Right. Exactly. It actually can make a fraction. So it's okay. So anybody give me 2 very famous irrational numbers. What is one? Pi. Very good. Pi is one of our irrational, right? Because that goes on forever. What's another one? How about square root 2? The square root of 2, if you put that in your calculator, you get a decimal that doesn't repeat and it goes on forever and ever. Okay? There's 2 very famous irrational numbers. So do we have a question so far? Okay. Let's work with this for a moment. Here is example number 1. Your first 2 questions on your homework. Yeah, it is. Okay. Shh, you guys, come on. All right. Let's say I want you to classify the variable that best describes a value. All right? And you're going to get a sentence. Let's say the number of days in the week. Number of days in the week. Okay? So what kind of number was that going to be? It's going to be a natural number. So all you have to do after that sentence is write natural. Okay? If I were to say the circumference of a basketball, first of all, how do you find the distance around the outside of a basketball? What's the formula? Pi r squared, right? Or no, 2 pi r, my bad, 2 pi r. It would be irrational, exactly. So you have a couple of them in your homework where it's going to give you a statement. You've got to decide where it fits in our 5 categories. Any questions at all? All right. Good deal. Example number 2. 15. Three through 5. Compare. And circle the greater value. So let's say I give you the square root of 5 and 2.27. In order to figure out which one's greater, we have to turn them into decimals. Well, the one's already a decimal, which means I've got to find out what the decimal is to the square root of 5. .236? Okay. So now that I have a decimal representing it, right, I've got to decide which one is bigger. The 2.27. So on my worksheet, after I write down that decimal, circle the bigger one. That's it. Okay? So maybe, let's do another one real quick. Let's say I have 15 over 4. And the square root of 15. I like it. So now I got to change them both to decimals. So 15 divided by 4 is? Good. The square root of 15 is? 3.87. Can I tell which one is larger? So we're going to circle the bigger one. Okay? Told you today was super easy. Example number 3. All right, I'm going to jump down to the last couple real quick. 14 and 15. Order the numbers in increasing order. All right, so from smallest to greatest. And let's see, maybe I give you square root 3. let's go 1.5, negative 2/3, negative 1.6, and let's go with the square root of 2. All right, so in order to put these in the right order, what do we have to change them all to? Decimals, absolutely. So we're going to start with the square root of 3. Good. This is 1.73. This one's already a decimal. Negative 2/3 is negative 0.667. Here I have negative 1.6. And what is the square root of 2? Okay. All right, so now let's put these in order. So here's the thing. When you put them in order, I need you to write them in their original form. So my very smallest number up here is negative 1.6. It's the furthest to the left. So I get negative 1.6. The next one is negative 0.667, which is negative 2/3. Whoops. Can't write very well. Try that again. So these are done. Then what? Good. Out of 1.73, 1.5, and 1.4, the square root of 2 would be next. 1.5, and then the square root of 3. Very good. Okay? Any questions there? Okay? All right, so now we got to talk about some other properties real quick. I know. Okay? Here are some of our properties. First one we got to talk about is the commutative property. The commutative property. The commutative property means things move. So maybe I have A plus B equals B plus A. That's if it's addition. If it's multiplication, I could have A times B equals B times A. The associative property. The associative property groups different things together. So, for example, if I have A plus B and then plus C, I can group it differently and have A plus B plus C. I can do the same thing with multiplication. I can have AB times C equals A times BC. Just grouping different things. Everything still stays in its same spot. We have the distributive property. The distributive property is a combination of addition and multiplication together. So you have a number or a value on the outside, and inside the parentheses they're adding things together. So the distributive property says I can multiply everything on the inside by what's on the outside. So A times B plus A times C. All right. We have two more. Hi. Yep. All right. The next property is what we call our identity. All right. The identity property, this is one of the newer ones. The identity property is whatever you start with, you finish with. So, for example, if I have A and I need to finish with A, what would I add to it for it to be an identity? What would I add to A so I still have A? 0. Very good. So that's the identity of addition. What would I multiply to A in order to get A? That's the identity of multiplication. All right. We're going to do the inverse. The inverse property. If I take A and add it to its opposite, I get 0. if I take A and add it to its, times it to its reciprocal, I get 1. Okay? Now, here is example 4. I think I'm on 4. No. We're going to do 6 through 11. Ready? Six through 11. Gentlemen, name the property. Name the property. So let's say I give you, how about 8 plus 4 equals 4 plus 8. And I need you, now that you're in Algebra 2, we got to say both words. It's the commutative of addition. I got to say of addition. Now, you got to at least give me 5 or 6 letters on the first word. Okay? I cannot let you abbreviate any of the words to 3 letters. I can't. Correct. Thank you. If we have the associative property, I can't shorten that. All right. So let's try this one. What if I gave you, let's say 2/3 times 3/2 equals 1? What property do you think that is? The inverse of what? Good. Inverse of multiplication. And you can write mult for me if you want. That's fine. Okay? So, do we have any questions on our properties? All right. You just got to look at your notes, compare them, and pick the right one. All right? Example number 5. This is the last one. Okay, guys. Hey. Yes. Yes, this is 12 and 13. All right, so I want you to simplify and, let's see, state which set of numbers. All right, so here's how it's going to go. You're going to be given b equals the square root of v divided by h. Okay? And I tell you that v equals 100 and h equals 25. So the first thing we have to do is simplify this. So I'm going to plug those in. All right, so I get the square root of 100 over 25. Whoops, that's not a 25. 100 over 25, which equals the square root of 4, which equals 2. So now go back to our original list. Out of our 5 different categories, where does 2 fit? It is a natural number. Is that all it is? It's also a whole number. What else is it? An integer. Is that it? And it's rational. Very good. Yes. And that's all you have to do for those 2 problems. Yep. That was it. All right. So